Hello everyone, welcome to a Scorpion Vision optics video. Today we're going to be talking about non-plane polarized light. So starting with plane polarized light, what that is that when the electric field of a photon, when its components in one direction and its perpendicular direction are in phase, i.e. maximum of this corresponds to maximum of that one, 0 corresponds to 0 and the minimum corresponds to the minimum. As these fields oscillate, they do so in a linear fashion. Now when linearly polarized light will enter a transparent medium, let's say glass, this component will be slowed down to by the same ratio as this one is. So when they emerge from the glass, it will still be linearly polarized because they both have just slowed down the same amount. Some materials, birefringent materials, will slow the electric field component in one direction down more than the other. So say I have light entering a particular birefringent material, and when upon exit, the maximum of this component corresponds to the minimum in this one, and the maximum here corresponds to the minimum of this. As we make our way around, we have a badly drawn circularly polarized light. In the video that will be appended to this one, what I had in my setup was a linearly polarized filter over my light source, blocking out one orientation of light, and on the lens, a polarizing filter blocking out the perpendicular direction, so the minimum of light is coming through. In between these two filters, I was stretching a material, making it birefringent. By stretching it, I'm changing its refractive index in the direction I'm pulling it, so that when I pull it here, I'm just changing its refractive index in this direction and nothing happens. But as I stretch it here, in between these two angles, all the light coming past that first filter has a plane polarization of this way, because it's blocking out all of this. Well, it's hitting here, but this angle here has a component in this direction and that direction. As one is slowed down by my birefringent material, it becomes either elliptical, one way, the other, but certainly not linear. And hence when I stretch it, we get brightness, but when I stretch it here, it remains dark. When I stretch it here, it remains dark. So this can be used for detecting stresses in transparent materials or a large range of practical applications. I hope you found that interesting. Thank you very much.